first, I made a tactical error and I prepared these slides with the presenter notes as like an integral part of my ability to see what's next. And there's no way to do that here. So I will occasionally be surprised by what happens next on the slide. And I apologize ahead of time for that. Right, so the slide that I made, I am here to talk about researching with undergraduates. In particular, my approach for that. Good timing, I just started. So when you start researching with undergrads, especially if you talk to your advisor or your friends or some of your colleagues, do you have a question already?
So I'll just say I will decide up, so if you think it's one too many.
Oh, okay.
I just felt the stress from this side.
It's been a roller coaster the last 10 minutes, guys. Right, you'll have some common advice. Things like undergraduates, in order to be productive, need concrete tasks that you need to be able to give them specific things to do with specific deadlines. Or that undergraduate students will require significant training. That in order to get to the point where an undergrad is productive on your research, you'll need to put in significant time, maybe even more time than it would have taken for you to do the task you're assigning your undergrad alone. But you'll also hear that it's an amazingly rewarding experience, that seeing an undergraduate student succeed on a project or being surprised by the insights that your undergrad brings to you is one of the best parts of doing research in the academy. And in my experience, I found that all of these things are true. And they also all sound like something else that we do in our careers as academics. It sounds like teaching. And what I'm here today to try to motivate is that we can view our research with undergraduates as a teaching experience.
Sorry. Apparently there is a lapel mic that
Do we need that?
I don't know if there is anyone. There is a virtual student volunteer.
Great. So I will stand here so that I'm on camera. Is that right?
I don't think that's necessary.
I don't think that's necessary.
Can you ask your
that's
virtual
not
student volunteer?
Don't worry about that part.
Sounds great.
Sorry about that.
All right, so in 2 slides, I have another good point to be interrupted with a logistical issue. So if you have a new one, please prepare.
So do you want to use this?
Yeah. Didn't I order something with lapels?
Yeah. What I remember is saying need to very close to mouse to that it will. Maybe we can try.
Well, I mean, it's not getting closer than this, so hopefully it works.
Yeah, good.
Cool, and I'll put this in my pocket. Tip number 1. If you happen to have a lot of clothing styles that don't include pockets, you're giving a talk at a conference, wear the one that has the pocket. You'll need it. Right. So where were we? I was trying to motivate you to think about research kind of like teaching, and in particular, frame your research experience for your undergraduates like a class. I think that plays to strengths of both the students that are used to sort of class structure and the PhD students that have experience.
Is anybody online on this meeting?
Well, I don't know.
Why is this connected to the speakers?
Guys, my talk's gonna go over time, just so you know. It's getting worse.
Probably battery.
Well, I tried to mute it.
You know how this works? No.
Maybe just mute it correctly on the
Okay.
device.
Well, so the main thing
So the
is,
device is muted right now.
Yeah, this one muted right now. Maybe with this one.
That wasn't muted.
Wait, what is the?
if we turn it off. Okay. So the thing is, everyone who's supposed to be at Doctoral is here. So I guess we'll stick you on that
I'm
part.
terribly sorry to the person online. I'm not going to give the entire talk into the lectern microphone just because it's a little bit complicated to do so while leaning over a table. So I think you're not going to be able to see this, and we will fix the technical issues for the next session, ideally. Also, if anyone is a student volunteer, for some reason the monitor for this computer has shut off. Great. I'm going to take one more try to get through this slide. So let's just go to the next slide. So what's the first thing that you interact with when, as a reminder, through the logistical issues, I've been thinking about researching with undergraduates as sort of a teaching experience for undergraduates, and in particular, trying to make analogies between researching with undergraduates and running a class. And what's the first thing that you interact with, or at least the first thing that your faculty member hopes you interact with when you run a class? Well, there's a spoiler on the screen. It's the syllabus. Syllabus is a planning document. It's a document that outlines things like what the class sessions will all cover, in what order they'll be covered. Things like how to set deadlines and assignments that can reinforce the lessons that are being taught through the sessions, all building up to a final assessment of some kind. In a project-based class, this would be some kind of final project. And because of the similarity between research and projects, I think I'm going to go with imagining a final project-based class. I also think that this has some implications for how we do our research. That if we think about research as teaching and we think about using class structure in research, we have to figure out what goes on our research syllabus. It has implications for how we select our projects, implications for how we design onboarding for our students. And it can help us see how we can run our project while making sure students stay motivated and engaged throughout the semester. This is a good time for logistical issues if you can save them. Good. So let's zoom in particular on selecting a final project, keeping in mind this sort of research as a curricular activity thing. So if you're selecting a final project, normally you'll hear that you want it to be some sort of mature research, something that has been going for a while and you can identify a lot of different tasks in. Something where you can find undergraduate projects that have measurable success, where you can understand how the success of that project relates to the success of your research, and also how to give feedback to your undergraduate assistant whether they are being successful. It's also helpful if this project has established prerequisites. If you understand what a student even needs to know in order to do productive research on that project. In order to keep the students engaged, it's nice to give them deadlines that are not, here is a paper, come back to me when you finish reading it. Great, please implement section 6, come back to me when you're done. Great, you've finished your undergraduate research. It's helpful if you manage to easily divide it into deadlines that are at the granularity that students are used to scheduling their lives. Especially initially, students will eventually learn to schedule into longer deadlines. So rather than go into more abstract details about what I mean by the sort of selection criteria, I'm going to talk to you about a project that I've done actually 2 different times with various undergraduate students. Technically speaking, this project is a type system, a substructural type system that ensures destructive race freedom for concurrent shared memory programs. Or you can think of it as a Rust-like type system that proves multi-threaded code is always thread safe. Roughly speaking, these 2 things mean the same thing. And welcome to Splash. So we're going to find projects in here that are at a mature stage of the research, where we understand how to measure success for the undergrads, where we've established the prerequisites of the research, or at least the prerequisites of that subtask, and where we can easily divide that subtask into a series of sub-deadlines. That's our goal. As I mentioned, I took a run of this twice. First at Cornell with a student named Ming, and second at Berkeley with a student named Josh. So keeping in mind our criteria, let me tell you a little bit about Ming. So I came to Ming at a pretty early stage of this research project. And at that time, I was relatively new to working with undergraduate students, and I wasn't really sure how to onboard anyone onto this project. So we kind of had to work on it together. Ultimately, we sat down and I said, how about you just go out and build an interpreter for this type systems-based language. And we can maybe use this interpreter to check with dynamic checks, but our type system wants to check with static checks. And in that way, learn a little about whether the type system works. How did this go? Well, does it satisfy our criteria? It didn't really have good measurable success. Now, this one might surprise you. I said just go out and build an interpreter, and building an interpreter sounds pretty concrete and pretty measurable. But the problem is, it wasn't clear that that interpreter goal really related to the research goal of a type system. It could be useful, it might not be. As the semester progressed, it kept drifting more and more. This is largely because the research direction wasn't mature. I wasn't coming to this project with an idea of exactly what the artifact a student needed to write would be. I had very vague sense. So as the students and I went together on our quest, we kept finding dead ends. Now in research you get a lot of dead ends, but that can be disheartening for a first semester research student. The student also didn't really get prerequisites from me. There were some clear ones, like you're writing an interpreter, so you need to know how to write interpreters, and there are software components there. But in terms of how to understand the system they were interpreting, I hadn't figured it out yet. So as the project went on, we kept having to take large pauses and go learn something that we wouldn't even use. However, it was pretty easily divided into deadlines. Building an interpreter has a lot of independent software components that you can make as partial deadlines. There are many classes that walk you through building an interpreter that give you inspiration for those deadlines. Overall, though, I think not a great project selection. So I tried again. At Berkeley, I got student Josh Turcotti. He came at a much later stage of the project. Josh's main project was to do proof work. The entire system at this point is written out on paper. I know everything there is to know, at least I think, about what the paper will look like, what the system should prove. Really, there's actually just a couple holes left where the proofs need to be done, and that's going to be Josh's project. I already know how to divide these proofs up into small subgoals, small demos, cases for structural induction that I hope will be good for laying out deadlines across the semester. And I can pretty confidently predict what success on these proofs look like. I mean, I've got the goals written down. If you prove them, you prove them. This one satisfies our criteria pretty well. We can measure success because the artifact of the research itself has already been built assuming that this exists. So the way it contributes to the research is easy to identify. It's also got pretty clear prerequisites. While this is a complicated theoretical project at this point, it's, as I said before, and of course you remember, a substructural type system. So there's already courses available, already material available that can teach systems like mining. We can easily divide it into deadlines, as I mentioned, by the fact that we can divide our proof goals and divide our limits. And it was so late in the project, so far into the paper, that it was exceptionally mature. It was very much at the point where if I was going to sit down and do this research, I would be ready for it. Okay, so those are a couple examples of project selection, a good one and a bad one. At this point, returning to our syllabus metaphor, we sort of unlocked our final project. We've got an idea of a final assessment and how we tie it to the student's success. But what happens at the rest of the semester? In particular, how are we going to get from the beginning of the class? Well, where does any research experience start with an undergraduate student? Naturally, it starts wherever the students are. It starts by understanding that the students have a set of knowledge and a set of skills that they're coming to your research with, and that those will be a lot of what contributes to their success, but not all of it. Because before we can do our final project, we need to understand where that final project is. And we need to find a way to build a path for our students that gets them from where they start to where the project starts. On this path, we might have things like intermediate assignments that aren't really for the research artifact, but reinforce a necessary lesson. Or we might even have interactive sessions, like not necessarily lectures, that's a big ask, but sitting down with the student with the goal of understanding the field or understanding the prerequisites more than just understanding this one component of their task. I'm sure I had something else to say on the slide, but I don't remember it, so we're going to move on. Let's dive deeper into like the bridging the gap part, again, via examples. So same example, fearless concurrency. This one's just going to work on the Josh part. So what do we start with? We start with where our student comes to us. So Josh came to me and gave me a course list and a GPA. And I immediately said, that's great. Let's set up a session where we can sit down and talk about things like, is a particular topic familiar to you? Or did you enjoy this course? Or did you just take it kind of like, I don't get it, but I got an A? When we sat down and we saw Josh's transcript was a mix of math and computer science courses, but Josh's background was 100% pure mathematics. He actually never heard of programming languages research before, seeing my posting, and hadn't written a single program in even a functional programming language. Which is interesting, because where Josh needs to get is to prove progress in preservation. So what do we need to prove progress in preservation? Well, we need an understanding of informal semantics, usually in operational semantics. All right, we need to know what semantics means in the context of a programming language. We need to know that a type system exists, how to phrase them in terms of inference rules, or how to read inference rules, what a judgment is. It's a giant lift. And getting from here to there is basically an entire course in programming languages, which turns out to be quite convenient. Because there exist entire courses in programming languages that are designed to take students with mathematical maturity and teach them the field. In particular, we used Benjamin Pierce's Types in Programming Languages and edited by Benjamin Pierce's Advanced Types in Programming Languages to build Josh's curriculum that was laser focused on the tasks at hand for a proof of progress and preservation in that style of type system, but that still built fundamentals, that still included lessons, that still included extra assignments selected from the textbooks. Now, crucially, at no point are we expecting that this is just like a 1 week or a 1 month thing, or even necessarily that this is something Josh is going to want to do. What we're doing is we're laying out a syllabus, and we're saying to Josh, just like you say to any student, this is the class you need to take to start this research. There's lots of other research that I can advise and that the department can advise. Do you want to take this class? And thankfully he said yes. And he actually did all of this in about 2 months, which was like legendarily fast. I've never seen someone read tackle in 2 months. Okay. Let's talk about another project. So I'm going to just take off my programming language hat for a second, and then go put on my distributed systems hat. This is a distributed systems project back at Cornell. It's called DERECHO. I don't have a handy overview of it here because it's in systems, but it's a state machine replication system. So we, as a research team, when we were building DERECHO, set out to really center undergraduate outreach and undergraduate involvement. We wanted to make sure undergrads contributed to the project. So we advertised it widely, and we wound up getting, at the beginning of one fall semester, about 40 undergraduate research assistants. There were 3 PhD students. 40 is too many undergraduate research assistants. Don't do that. So we had to figure out a way to take our 40 undergraduate research students and do right by them, because a very senior professor had already promised them research. And so what we did is we took our class design idea of much more literally than usual. We built an actual course for them. We wrote out assignments, we got a course number from the department, we wrote out lecture ideas, we traded off. Everyone got TA credit for it. And at the end of that semester, about 15 of those students finished the course, really enjoyed their work there, and decided to continue with DERECHO as research projects, which wound up being 5 per PhD student. Still quite a bit, but not terrible. So this one's, I'm not going deep into the prerequisite design for this one because it's a bunch of like distributed system specifics, but it took us about, I would want to say 2 weeks of just meeting every now and then to really build out the syllabus for the course. And actually running it was like an hour a week. Thankfully, when you're building a course about something you desperately and deeply know, desperately knows a weird sentence, you're not going to need to prep that much for the lecture. You only need to learn how to teach it, not how it works. God, don't repeat that. Please prep for your lectures. Okay. Let's go back to our syllabus for research. Where are we now? Well, we identified a final project, which had 4 criteria for success. That had to be mature in particular, and that we used its established prerequisites in order to build a pathway where our students could learn from the beginning of the semester to the beginning of where their project was going to start. Now let's see how we can use the fact that our project was easily divided into deadlines to further refine our sort of syllabus design idea. Now, thinking for a moment about some project-based courses you might have taken. When the final project is truly huge, as a research final project would be, it doesn't tend to just happen right at the end of the semester and everything stops for it. But rather it's interleaved, with early deadlines occurring in between traditional lectures and maybe even in between some current assignments. What does this mean for research? Well, it suggests to me that there doesn't have to be this big discontinuity between the part of the class where you're working on your final project and the part of the class where students are doing their onboarding. But rather you can have a gradual transition. You can sort of take the lessons that we learned from selecting our project and apply them to our individual subtasks, deferring things like, for the DERECHO students, how to do like RDNA debugging, until after they've already started to get engaged with the research, interleaving the deadlines as early as they can get. This is pretty important for engagement. It's really great and wonderful to have early deadlines for your students, and that makes it so that it's easy to see if they're keeping up or excited or falling behind. But I know personally, if I was given like 3 months of work before I was allowed to think about research, I'd be quite frustrated. Don't remember why it's there. All right, let's go back to an example and talk about sort of the interleaving of deadlines in these projects, and in particular, how we divided up our final project task. Back to Josh. So Josh is going to try to prove progress in preservation, and at this point, he's finished reading TAPL and ATAPL, so we are set there. So Josh's first task is going to be to read my type system. In preparation for that, what I'm going to do is I'm going to reformulate my type system to look a little more like David Walker's style in the first chapter of Advanced Types and Programming Languages. The idea being this way, Josh's assignment to read the project he's actually going to work on isn't suddenly learning a new style, it's continuing with the standard he learned. His first concrete task is going to just be to explain that system back to me, to tell me about it, and in particular to tell me why it works or what the key insights are that says this type system is correct. And I'm going to help him refine those explanations in sort of a loop. The idea here is that as we refine these explanations and as they get simpler and closer to the system, they wind up basically being the invariants you're going to need to prove in order to demonstrate the system works. They wind up being subgoals for your proof. Once we've gotten to that point, we formalize them. Josh's task is to say, all right, you think that this works because this object structure forms a tree at all function boundaries. Let's write down what that actually formally means in terms of the object model we have. Now, I'd actually done this part before. I did this ahead of time. And the idea was that I could therefore compare results with what Josh came up with. At this point, we're doing real and actual research. I don't have any a priori reason to think that my version of these invariants is going to be easier to work with or more correct than Josh's. But if Josh and I come up with roughly the same invariants, it's going to lend a lot of confidence to the idea that these might actually be the arguments that work. Whereas if we come up with different ones, it points out where there's some fuzziness left in our mutual understanding of the system. As it turns out, Josh and I came up with the same invariants, which is good. After we have those invariants, we're going to go prove some lemmas. And as the semester starts, I'm going to start easing off of the sort of hands-on nature that I've been articulating, giving Josh, some lemmas that'll take weeks, some lemmas that'll take a semester, well, no lemma, but some full proofs that'll take a semester. This is important. Giving undergrads agency is once they're used to it, once they understand what the actual task is and they feel engaged, no need to break it down into daily tasks. At the same time, though, pay attention. For Josh, at the point at which I was giving him month-long proof tasks, he was doing really good research, but every now and then we check in about once a week, and I detected he was stalling. When I went back to see why that might be, it turns out that he was stalling because one of his proof cases wasn't going through, and one of his proof cases wasn't going through because I had a bug in my system. So if I'd given Josh concrete test deadlines, we would never have gotten to that point until much later in the semester. But if I had given Josh no oversight, he would have just gotten frustrated and burned out trying to prove a false fact. It's important to balance them. Meanwhile, in DERECHO, so our concrete task here for the students, our overall task is to build a new allocator framework for DERECHO, so a new memory allocator for DERECHO. And our first task is going to be to just work in a private code base to build a small scale version of that allocator design just in their own C++ project, using the resources and IDEs and libraries that DERECHO tends to use, so that's a familiar ecosystem, but without having to bite off an entire, I think like at that point, 300,000 line research code base in order to start. Once we got our prototype up, we actually did the complete artifact lifecycle. We worked on benchmarks, we worked on write-ups, documentation write-ups, and as benchmarks produce results, we go back to the allocator and refine the design. The idea was once the design stabilized and the benchmark showed that in laboratory conditions, the allocator satisfied what we thought the performance conditions should be, we'd actually go integrate it into the main system, at which point we learn the main code base. For the DERECHO students, we didn't actually wind up doing a ton of weaning off the gas. It was a very busy semester for them, and 5 students takes a very special group of 5 students to perfectly balance tasks with no oversight. So we kept deliverables on roughly a weekly basis. So where are we now? We've taken our final project, we divided it up, we talked about getting a student from point A to B by having a project with easy prerequisites. The only thing we haven't really seen yet is how to measure success of our projects. So it's time for the scorecards and for y'all to see how this went. As we're doing this, remember that we're here to teach. Measuring success of a project is by far the hardest thing about it. And when I try to measure my own success, I think about my success as the success of the students learning what I set out to teach. Learning how to successfully do research in my area, staying engaged, learning that I love research and that research is fun, and deciding for themselves how they want to do it. And I measure success much less about the research going as expected. It's research. If there was a giant bug in my type system, Josh wouldn't have finished a proof because it would have been false. That does not impact his success. So some scorecards. DERECHO. It didn't work. So I came up with an allocator design that I thought was really clever, based around a series of tiered slab allocators that could be like flipped over the network as single units. And it was really cool, but it fragmented too much. So ultimately, we found the performance results weren't competitive with more traditional allocator strategies. But the students really were engaged. After we found it out the first and second and third time, they were coming back for more. They were trying to keep figuring it out. They were debating us their own designs. They were really doing the research. They gained the skills and knowledge that we set out to teach with this experience. And they went on to have subsequent successful research opportunities elsewhere in DERECHO and at Cornell. And I think 3 of them are in grad school now, of the 5, but I don't put them in. Meanwhile, let's return to Ning Ning. As it might have been presaged by the way the project selection didn't go well, Ning Ning's project worked a bit poorly. I just wasn't able to keep up with his needs. By the middle of the project, Ning Ning was finishing tasks excellently, staying on deadline, and I just didn't know what was next because I didn't know how the system worked yet. Because of that, I kept giving Ning Ning deadlines that drifted from the actual research needs but that I could articulate. And ultimately, those deadlines ran out, and Ning Ning was left to his own devices to come up with tasks. He did a brilliant job of this, but ultimately decided to leave the research because it wasn't that fulfilling. Try number 2, though, learning from my failures, was really quite successful. The project worked. Despite everything, after that one small bug, this giant type system actually just went through as expected. So Josh finished that 2-month-long course that was basically graduate programming languages but self-taught shouldn't have been able to expect that. Gained tons of skills and knowledge in programming languages in the process. Josh stayed fully engaged and has worked on other successful research subsequently. In fact, after we finished working on this, Josh applied to graduate school and decided to select to go to my advisor to be able to continue working in this area. And when Josh started research, he wanted to go to a financial trading firm when he graduated. So a single research experience can really show a student that there's so many more options in the world. And think what you will of financial trading firms, but sometimes that could be a good thing. We published our paper. It came out in the LBI, and so in all ways, this was a very successful project. So let's just review. We selected our final project. We identified that if that project is mature and has measurable success, and that if we can establish its prerequisites and divide it into deadlines, then we have the tools we need to build sort of a syllabus for research that shows our students how to get from where they start to the end of their project, while keeping them engaged with regular deadlines and regular feedback. And I'm just going to close with a quick PS. I am one person standing up here saying what worked for me at a relatively junior stage in my career. And everyone here, especially the back row here, probably has a lot of exciting and interesting ideas about how to research with undergrads yourselves. Some of you maybe have research experiences as an undergrad that you loved and you want to replicate. And I'm really excited to hear about how that research experience went for you, or what your ideas are, or how you would tweak my plans if you had the opportunity to. And I'm going to finish there. Any questions? Yo.
So how much time do the students have to this? Like, is this one course for the whole, like one research project for the whole semester? Do we have other classes and so on? So I feel like that impacts a lot of how much you can give students to do it.
For sure. So there's basically two dimensions of time management. The one is the one you asked about, which is what are the students doing? The other one is what are you doing? So a lot of the things I was talking about here are a lot more time for the PhD student than, say, sending them a paper over email and then never hearing from them again. So you really have to balance what time you have and what time the student has. For all of the examples I presented, the students have roughly the same thing going on, which is a normal course load. And for all of them, I basically sat them down at the beginning of the semester and said, hey, how much time do you want to devote to research? And they'd say something like, well, I feel like I have 10 hours. And I said, okay, great. So let's imagine for a moment that you never do homework on Monday or Tuesday night, just at all. Like Monday just doesn't exist. Is that fine? Like, is that gonna work okay, or does that sound scary? And we worked together to sort of understand what the actual level of commitment they wanted to be. And once we had that knowledge, it was easier to schedule the semester. Josh in particular had 3 graduate level math classes and basically said immediately, these things are really easy. And I said, all right, 2 things just happened. A 19-year-old told me graduate math classes are very easy. And this student says that they have a lot of time. So I was like, yeah, I'll just throw the book at them and see if it works. But Josh is a massive outlier. For the DERECHO students, there were 40 of them, and we thought the fairest thing to do was give them course credit for their research because we weren't sure if we'd be able to keep all of them. So we told them at the beginning of the semester, and they had, I think they were carrying about 3 or 4 courses other than this one. And so far, none of them have reported the research was like too hard or anything. The nice thing about like the research syllabus is, unlike a class syllabus, you can just change it in the middle of the semester. If your student's not making deadlines, that's not their fault, that's your fault. Make the deadlines longer, change the goals you have for the semester. Did that actually answer your question?
Yeah. But I was surprised you saw for some of the projects the students didn't get credit, or like course credit.
So students are at Cornell and Berkeley either paid or given course credit for their research. I personally think I prefer to pay them. I believe that all students deserve compensation for what they work on, and at Cornell and Berkeley, the pay rate is kind of fine. Also, there was basically 0 undergraduates that I found who were hurting for credits. Almost all of them were ready to graduate early, or otherwise needed classes that couldn't be just generic credits, they needed to be in their major. So the credits were actually not very useful for them. For the DERECHO class, we got that to count as like a systems senior elective, so it could fulfill our requirements. But generally speaking, an education study is not going to manage that. Yeah, so that's where I come down. I know a lot of people just work with undergrads without paying or giving them credit or always give credit. It's a
Like,
large set
Hard
of
to motivate
options.
them.
Honestly, like,
Or you get people self-motivated to just put way much time to their work.
yeah, that's the thing. Like, motivation doesn't really, is not remotely in proportion with money. I think we need to switch to
Thank you.
the, like.
Sorry, I guess there may be more questions, but we're running kind of short on time, and we do want to get through the elevator pitches. But May is around for, the rest of the conference, so, you can find her and talk to her later during the day or the week. So, thanks again, May.